Good morning, students. Today we will discuss remaining questions of limits and derivative exercise 13.1. So in previous class I explained till question number 22. So we'll move forward. Now we see the question number 23 onwards. So in question number 23 it is given you have to find limit x tends to 0 fx and limit x tends to 1 fx. Okay, means you have to find limits at x equal to 0 and x equal to 1. Your function is defined as fx is equal to 2x plus 3 when x is less than equal to 0 and 3 into x plus 1 x is greater than equal to 0. So in these questions you have to take care while calculating left hand limit and right hand limit. So we'll calculate both left hand limit and right hand limit. If both limits are equal, then we'll say that limit exists. Okay, because single function is not defined in these cases. Separate functions are defined at x equal to 0. So you see what to do at x equal to 0. We have to calculate left hand limit. Left hand limit. Left hand limit. So whenever you have to calculate left hand limit, we'll consider fx equal to that function which is defined at value x is less than 0. In all these questions, you have to follow this thing. In left hand limit, we'll write x tends to 0 minus. Left hand limit means limit x tends to 0 minus. 0 minus. For this, we'll take fx equal to that function which is given at value x is less than 0. Like in this case, it is given x is less than 0. When we'll calculate right hand limit, right hand limit is expressed as we are calculating at x equal to 0, so it will be expressed as x tends to 0 plus. 0 plus means it is right hand limit. So x tends to 0 plus, or in right hand limit we'll consider the function which is defined at value x greater than 0. 0 plus means greater than 0, or 0 minus means less than 0. So while calculating left hand limit at x equal to 0, we will take the function which is defined at x is less than 0, and while calculating right hand limit we will take the function which is defined at x greater than 0. So whatever value of x is given, like in this we have to calculate at two places, at x equal to 0, at x equal to 1. So in similarly at x equal to 1, x equal to 1 you have to take same function in left hand side as well as right hand side. Why? Because for x greater than 0, x equal to 1 lie at the point x greater, in this region it will lie. X equal to 1 will lie in which region? X greater than 0. So both sides will consider this as the function. Now see, at x equal to 0, I will calculate limit. So for left hand limit, as I explained, we'll write left hand limit is how to write and how to put the values, just note it down carefully. X tends to 0 minus, it means it is left hand limit. So for 0 minus, I will take this as the function which is defined at x less than 0. This function I will take. So I have taken it as 2x plus 3. In this you just put x equal to 0. So 3 is the left hand limit. Now I will write it as limit x tends to 0 plus. 0 plus means right hand limit. For 0 plus, we will take the function which is given at value greater than 0. 0 plus means greater than 0. 0 plus something. Okay, it means greater than 0. So we'll take this as a function, and this you put x equal to 0. So we will get 3. Now we'll write that x tends to 0 minus means left hand limit equal to x tends to 0 plus, both are equal and both are equal to 3. So this is the value of limit at x equal to 0. Suppose you want to calculate at x equal to 1. So x equal to 1 in left hand as well as in right hand, we'll use the same function. Because at x equal to 1, x less than 1, the function is same. X greater than 1, also the function is same. So in left hand limit, we are using at x equal to 1, it is 3x plus 1. So it is coming 6. and right hand limit also we'll write limit x tends to 1 plus fx. So x equal to 1, both sides this same function is given. So we'll get 6. Come to the next question, question number 24. Again, you have to calculate limit x tends to 1. Now you can understand it very well. We'll calculate x 1 minus means less than 1. This will be the function that is left hand limit. We'll calculate x tends to 1 plus means slightly greater than 1. Then we'll use this as the function. So I will calculate left hand limit 1 minus. I will take this as the function x square minus 1. In this you put x equal to 1. You will get the 0 answer. And when you have to calculate 1 plus, so you take this as a function x greater than 1. In this put x equal to 1. You will get minus 2, as in this case left hand limit is not equal to right hand limit. So we'll write that limit does not exist. Question number 25. It is at x is not equal to 0. So in this case, at both left hand limit and right hand limit, we'll use the same function, limit x divided by x. Both left hand limit and right hand limit. So I am calculating left hand limit, limit x tends to 0 minus fx. In 0 minus fx means x is less than 0. So when x is less than 0, modulus of x is written as minus x. When x is less than 0, modulus of x can be written as minus s. That I have already explained in one of the videos. You can check it, how to calculate modulus. So we'll replace this modulus of x as minus x. So it is minus x upon x, so it is minus 1. When we'll calculate right hand limit, we'll write limit x tends to 0 plus fx. When means x is greater than 0. 0 plus means x is greater than. When x is greater than 0, modulus of x is equal to x only. So we'll write it as x upon x. So that would be equal to plus 1. So in this case also left hand limit is not equal to right hand limit, as left hand limit is minus 1, right hand limit is plus 1. So limit does not exist. Question number 26 is just similar to the question number 25. In this also in left hand limit, what will you do? You will write modulus of x as minus x, so it comes out to be minus 1. In right hand limit, when x tends to 0 positive means greater than 0. For greater than 0, modulus of x can be taken as plus x, so it will come 1. So the same question is repeated actually. 25th and 26th have the similar solutions. Only difference is in 25th modulus is given numerator, and 26 it is given in denominator. So this limit also doesn't exist. Come to the question number 27, sorry. Limit x tends to 5, modulus of x minus 5. So we'll calculate limit x tends to 5 minus fx. 5 minus fx, limit x tends to modulus of x minus 5 fx. So for this modulus of x is as x is greater than 0, 5 means it is greater than 0. So the modulus of x will take it as x only. So it will become x minus 5. You put x equal to 5, the value is 0. Similarly, x tends to 5 plus fx, right hand limit. It is also known as right hand limit. So limit x tends to 5 plus. In this also modulus of x is equal to x only, because 5 is greater than 0. For all the values x greater than 0, modulus of x will be plus x. For all the values x less than 0, modulus of x will be minus x. So again it is equal to 0. So left hand limit 0, right hand limit is also 0. So the value of this limit is 0. Question number 28 is like this. Suppose fx is given a plus bx if x is less than 1. 4 if x equal to 0. b minus ax if x is greater than 1. Limit x tends to 1, fx is f1. What are the possible values of a and b? Limit x tends to 1, fx is f1. So again we will calculate left hand limit, right hand limit. There is actually some mistake in question. This is not x equal to 0, this is x equal to 1. Okay, this is x equal to 1. So left hand limit we will calculate. So in left hand limit, you know, limit x tends to 1 minus. So for 1 minus, which function we will use? This will be the function. So I have replaced it as a plus bx. Put x equal to 1, it will be a plus b. Limit x tends to 1 plus. 1 plus means right hand limit, as we are calculating at 1. So 1 plus, we will use this as a function b minus ax. So it is b minus a. Now you see, limit x tends to 1 is given equal to f1. So what is f1? F1 is 4. So this thing is given 4 and this thing is also given equal to 4. Because left hand limit and right hand limit both are equal and both are equal to f1. So a plus b is equal to 4. A minus b, b minus a is also 4. You simplify these two equations. On solving the equations, you will get a is 0 and b is 4. So that is the answer of this question. Question number 29th. Let a1, a2 up to an be the fixed real numbers and define a function. Fx is given x minus a1, x minus a2 up to x minus an. What is the limit x tends to a1 fx? So in limit x tends to a1 fx, you put x equal to a1. In this, if I will put limit x tends to a1 means I will replace x by a1 in this whole expression. So the first one limit x tends to a1, x minus a1 will become 0. As this first one limit becomes equal to 0, so the value of this whole limit will be 0 only. Second part of the question is compute limit x tends to fx. So in this whole expression, you simply replace x by a. So it will become a minus a1, a minus a2, a minus a3, and that would be the answer. Now come to the question number 30. It's asking for what values of a does the limit x tends to a fx exist? This is one of the important questions. For what value of a limit x tends to a fx exists? Means we have to find all the values of x for which this limit exists. All the values of x for which this limit exists. So what we'll do actually, first at x equal to 0, we can easily calculate the limits. So we'll calculate the limit at x equal to 0. Okay, because in left side of 0 and right side of 0 function is given. So we'll calculate at a equal to 0 first of all. Value of x equal to 0 means x equal to a, at a equal to 0 we will calculate. So for left hand limit, I will use this as a function, modulus of x plus 1. And when x is less than 0, you know that modulus of x is minus x. So I have replaced this modulus of x as minus x. Its value is 1. Now at x equal to 0, we will calculate the right hand limit. So we will write limit x tends to 0 plus fx. For 0 plus fx, we will use this as a function, modulus of x minus 1. But when x is greater than 0, means 0 plus modulus of x is x only. So I have replaced this by x. In this, I have replaced modulus of x by minus x. In this, I have replaced modulus of x by plus x. So put x equal to 0, you will get it is minus 1. So at x a equal to 0, your left hand limit is not equal to right hand limit. So at x equal to 0, fx does not exist. So at 0, this function is given. Now we'll take 2 points. We'll take all the points less than 0 separately and all the points greater than 0 separately. At those 2 points also we'll calculate. Now I am taking point a is less than 0. Like you can take minus 1, minus 5, minus 7. Less than 0 any point. So x tends to a minus fx. In case of less than 0, in a minus you will take this as a function and a plus also you will take this as a function. It is a is like any point less than 0. Less than 0 means suppose you are calculating it at minus 5. You can understand like this. Okay, at 0 we have checked, it doesn't exist. Now we'll check for all the values less than 0 separately and for all the values greater than 0 separately. So first we will calculate for all the values less than 0. All the values less than 0. So for all the values less than 0, in left side as well as right side, we will take this as a function and we will replace modulus of x by minus x. Because for all the values x less than 0, modulus of x will be minus x. So I have taken a is less than 0. A is any number which is less than 0. It can be any number. So limit x tends to a minus. So modulus of x will be replaced by minus x. Now we put x equal to a, it will be minus a plus 1. Now we'll calculate means right hand limit a plus. Then also you have to use this as a function. Same function we'll take. Note it down, okay? A less than 0, you have to take the same function. When we'll calculate a greater than 0, we will take this function both the sides. So now modulus of x is again minus x only. because these are for negative values of x, so it is also minus a plus 1. So x is equal to a less than 0, the limit exists. Now a greater than 0 will calculate. For greater than 0, we'll take this as a function, and modulus of x will be replaced by x only, because we know that when x is greater than 0, the modulus of x is equal to plus x. So we'll replace modulus of x by x only. Function will take same. For a minus we'll take this function. For a plus also we'll take the same function. So the modulus of x, it will become a minus 1. For a plus also we'll take it is modulus of x minus 1. So it is again equal to a minus 1. So at x equal to a means for all the values of a, in this question you have to understand the question like this. At a we are checking means 0. It doesn't exist. What are all other numbers? One category which are less than 0 means all negative numbers, and one category which are greater than 0, all positive numbers. So when we are calculating for all less than 0 means for this is for all negative number. Take care of this. A less than 0 means for all negative numbers. For all negative numbers, we'll take this as a function for left hand limit as well as right hand limit. This is for all positive numbers. We'll take this as a function. When x is greater than 0 means for all positive numbers. Question number 31st. Limit x tends to 1 fx minus 2 upon x square minus 1 equal to pi. Evaluate limit x tends to 1 fx. So you apply limit in left hand side on fx separately, numerator and denominator separately. This denominator limit you can cross multiply with this. So it is limit x tends to 1 fx minus 2 is equal to pi into limit x tends to 1 x square minus 1. In this you can put the limit. Limit x tends to 1 x square minus 1 is 1 minus 1. So pi into 0 is 0. So limit x tends to 1 fx minus 2 equal to 0. Limit x tends to 1 fx minus limit x tends to 1 2 equal to 0. And limit x tends to 1 2 is 2 only because there is no x. This is 2 only. You can change over this 2 to this side. So it is limit x tends to 1 fx will be 2. That is the answer of this question. Now come to the question number 32. It is given if this limit x tends to 0 fx and limit x tends to 1 fx exist for what integers m and n. No problem. First of all, at x equal to 0 we will check calculate limit. So left side of 0 will take this as a function. So left side of 0 I have taken mx square plus n as a function. In this put x equal to 0, it will be n. Now right side of 0 will take this as a function. You see, x greater than 0, this is the function. So right side of 0 means limit x tends to 0 plus fx. We'll take this as a nx plus m. In this put x equal to 0, so it will be m. As this limit exists, it means n is equal to m is the answer. Limit also exists at x equal to 1. So left side of 1 will take this as a function nx plus m. In this put x equal to 1, it will be m plus n. And right side of x, you will take this as a function nx cube plus m. In this you put x equal to 1, it is also m plus n. So these both are actually equal. So for all the values of m and n, it will exist. You can take any integers. So the answer of this part is thus limit x tends to 1 fx exists for any integral value of m and n. For all integral value of m and n, it will exist. So in this way, this exercise is complete. Now you can do all the questions, and in case of any problems, you can ask me. Try all the questions yourself and take the help from this video only if you stuck somewhere. Thank you.